So put in there attempt date by the end of Sunday. So by Monday, you should already have an attempt. So attempt by 01, what's today's date? 10 to 11, 12. 01, 12. And we'll make this one a week, which is the usual 01, 17. I don't think you will need that time, guys, because half the questions are graph. So that means that you guys will probably get these. You'll probably get 100 on your first attempt or second attempt. Guys, please make sure that you're doing this without the assistance of Wolfram Alpha or some type of AI. Because we want to make sure that you are, getting it done like the right way. That you know what you want to make sure that you're going through all the sweat and all that good stuff. So that way you've been battle tested. All right, here we go, guys. Question 1. The graph of f prime, the derivative of f of x is shown below. Find the critical numbers of f of x. Critical numbers are where the derivative equals 0 or undefined. So let me write that down. If f prime is 0 or undefined, that's a critical number. This graph, what graph am I looking at? What graph am I looking at, guys? F prime. So all you got to do is find where you have zeros, where you cross the x-axis. Bam, bam, bam. Sorry, you don't need the sound effects, but there it is. So -6, that looks like -1 and x equals 6. So look for those three, and that's the answer. Yeah, see? Easy. Next question. So they tell you, suppose that c equals -3, so that's an x value, an x coordinate, and that f prime equals that. So they're telling you the derivative. Determine if it's a local max, local min, or neither. Okay. I would not do first derivative test. Okay, time out and let's talk about the scenarios. If your first derivative changes from positive to negative, it's a max. If your second derivative changes from negative to positive, it's a min, right? Think about it. Positive to negative, max, negative to positive, min on f. We're not going to do the first derivative test for this. They're already giving you the first derivative. You're not going to find your zeros. They're already telling you that -3 is a critical number. All you care about is, at that critical number, are you concave up or concave down? Because look, if they're telling you it's a critical number, that means that my derivative is either 0 or undefined. So most of the time it's going to be 0. So look, guys, if I'm concave up, boom, it's a min. And if you're concave down, boom, that critical number is a max. Do you guys see what's going on? So I'm going to take the second derivative there. This is the first derivative. And I'm going to plug in a -3, and all I care about is if it's positive or negative. Is it concave up or concave down? If the second derivative is positive, f is concave up. If the second derivative is negative, f is concave down. Does that make sense? All right, here we go, guys. F prime of x equals 3x squared plus 10x plus 7. I don't see any issues. Let me know if I make a mistake. I make mistakes all the time, guys. F prime of -3 equals 3 times -3 squared plus 10 times -3 plus 7. Let's see what's up. -3 squared is 9. 9 times 3 is 27. 10 times -3 is -30 plus 7. All I care about is positive or negative. -27 minus 30, that's a -3. But when I add 7, it's going to be a positive. So this is the situation I have. You're concave up at that critical number, so it's going to be a what? A local min. By the way, this is called the second derivative test. Second der test. Don't abbreviate. Say the actual word derivative. Okay, I have bad habits, so let me go ahead and try to have good habits. Second derivative test. How do we feel? Not bad, right? Do we have any questions, guys? Hit me up. Okay. All right. Oh, wait. I was going to say, and we know it's minimal because the first derivative is 0, and the second derivative is positive. They already told you that -3 is a critical number. And you're only a critical number if my first derivative is 0 or undefined. You know what I mean? Okay. It has to be a critical number, and then you test it. All right, and then we get a graph again. This graph, before you even do anything, I would label it. What graph is this? Label it f prime. Find the intervals on which f decreases. Well, f decreases wherever f prime, that's just a prime, not 2 prime, wherever f prime is negative. So where is f prime negative? When I'm below this x-axis. So it looks like negative infinity to negative 2. And it looks like from 2 to infinity. So negative infinity to negative 2. And UH has a habit of putting parentheses instead of brackets. That's fine. It depends on what textbook you use or what textbook they use. But no big deal. Delta would have had brackets on that. Hopefully you remember when you increase, decrease on an interval, but it's not a big deal, guys. Cool or not cool? Okay, let's go to the next one. Check it out. This is why these go really fast because of the graphs. The graph of f prime is shown below, so label it. This is f prime. Where is the graph of f of x decreasing? Again, whenever it's below the, so negative infinity to negative 1, and then from what to what? 0 to 2. Let's look for that. Negative infinity to negative 1. I'm going to put a bracket on the negative 1. And 0 to 2, I'm going to change the parenthesis to a bracket, but not a big deal. All right. See, look, we're already halfway. This is why these sometimes go fast. Let's see if they make life hard for us. Find the critical numbers of f of x equals 5x to the fourth minus 10x squared minus 1 and classify all local extrema. Okay. By the way, this has no absolute. Is there anything that says absolute max? Oh, it might have an absolute min, but it does not have an absolute max. No absolute max because of the end behavior. 5x to the fourth goes up forever. It might have an absolute min, though. All right. First, let's find our critical numbers. Take a derivative. The derivative of that is 20x cubed minus 20x, and I don't see any issues. Let me know if there are any. I'm going to factor out a 20x, and I'm going to have x squared minus 1. Oh, I hear Tom talking smack. Hello, guys. No, they weren't talking smack. All right, critical numbers. I have a critical number at 0 and a critical number at positive and negative 1. Do we have any issues on that? All right. So I'm going to look to see if letter B, delete. It says no critical numbers. You know you do because, look, you just found a whole bunch of them. The next, we're going to have to critical number 0 and let's see, critical numbers plus minus 1. And okay, so letter A, delete because it doesn't tell you anything about critical number being 0. So it's between C. Nope, C's out also because it doesn't tell you about critical number 0. Look at that. Man, you can just look, just by critical numbers, you can get the answer. Critical number 0 and plus minus 1. That is a true statement. And then it says local min at negative 1 and 1 and local max at 0. What I would do for that, guys, I know that the answer is D just by process of elimination, but I want to do it the right way. Here's f prime, and I'm literally just going to go 0, negative 1, and 1, a sign chart. All you care about is the sign, positive or negative. And look how easy it is to do it. Pick a number to the left of negative 1, like negative 10, negative anything, negative 2 if you want. 20 times negative 10 is a negative number. Negative 10 squared is 100, minus 1 is a positive number. Negative times a positive is a negative. Pick a number like negative 0.5. 20 times negative 0.5 is a negative number. Negative 0.5 squared is negative 0.25. When I subtract 1 is another negative number. Negative times a negative is a positive. Pick a number like 0.5. 20 times 0.5 is a positive number. 0.5 squared is 0.25 minus 1 is a negative number. Positive times a negative, negative. And if I pick a number bigger than 1, like 10, positive times a positive is a positive. So at negative 1, you read a graph left to right. At negative 1, you're going from negative to positive, so that is a min. At 0, you go from positive to negative, so that is a max. And at 1, you go from negative to positive, so that is a min. So hopefully letter D says that. Local min, yep, and local max. By the way, these are the outputs of the y value. If you type in negative 1 in here, you will get negative 6. If you type in a 1 in here into the original, you will get negative 6. Does that make sense, guys? If you type in a 0, you get negative 1. Look, 0, 0, negative 1. There it is. So these are the outputs. Output of f of x. You can also say the value. Output of f of x at x equals 1, or I guess output of f of 1 instead of saying all that, but not a big deal. All right, go to the next one, guys. Ooh, I'm gonna go this one. I'm gonna do this one slow. Okay, I'm not trying to teach you to the test, but delete the answers that are just wrong. Look at this function. X equals 0 is a vertical asymptote, not a critical number. Do you guys see that? Delete the answers that are just dumb. Anything that says that 0 is a critical number, delete. Critical number 0, out. Critical number 0, out. Let's see. Critical number 7/4, local max. Critical number, no critical. Okay, so there it is. So we deleted two of them. So now you got a 33% chance of getting it right. I'm going to take a derivative and I'm going to equal it to 0. And obviously you know that there's no critical numbers, but let's see what happens. I'm going to go f prime of x equals 8x minus, by the way, the 7x squared is 7x to the negative 2. So negative times a negative is a positive. 7 times negative 2 is negative 14, but minus a negative, so plus 14x to the negative 3. I'm going to rewrite this. 8x plus 14 over x cubed equals 0. Have I lost anyone? Okay. I'm going to solve for x if possible. So I'm going to try to do algebra. So let's see. I'm going to move. Let's see. What should I move? I'm going to move this one over there. 8x equals negative 14 over x cubed. And I'm going to multiply both sides. Yeah, they're going to trick a lot of people here. I'm going to multiply both sides by x cubed. Whatever you do to one side, you do to the other. That way you can cancel those x cubes there, and you have 8x to the 4th equals negative 14. I don't see any issues. Divide by 8, divide by 8. Actually, you can stop. Well, stop right here after this. X to the 4th equals negative 14 over 8. Okay, and I'm going to stop right here. Is it possible when you raise something to the 4th to get a negative number? Nope, not possible. No critical numbers. And then put in your notes in there. Anything raised to an even power is a positive output. So you know why. Anything raised to an even power is a positive output. Not possible to get that. If you try to do the 4th root of that, you'll get an error message. Man, I can't believe the audacity of them to put 7/4 in there. But, okay, anyways. Because that reduces, right, to 7/4 negative. But obviously it's a negative and they put a positive. But, man, they're just tricksters. Okay. I don't see any issue. Yeah, we got that one right. All right, here we go. Classify extreme values given. Okay, you see how you have a closed interval? Put this down, guys, real quick, because 1 year, I think 1 year, by the way, that year we had like 92% qualifying, but 1 year I didn't talk about the extreme value theorem enough because I didn't really see it as a big, all the extreme value theorem says if you have a closed interval in a function, you must have an absolute max, must have an absolute min. So put that down in your notes. Extreme value theorem states if function is continuous, comma, there must, on a closed interval, continuous on closed interval, comma, there must, underline must, be an absolute max and min. There must be an absolute max or min. Yeah, extreme value theorem states if function is continuous on closed interval, there must be an absolute max min. That's it. All right, here we go. Let's find critical numbers if there are any between negative 1 and 0. F prime of x equals 8x plus 2. Equal that to 0. Let's see, what do I want to do? 8x equals negative 2. X equals negative 2 over 8, which is negative 1/4. Is negative 1/4 between negative 1 and 0? So I do have a critical number. Critical number 0. No, okay, 0 is an endpoint. So delete anything that has the endpoints as critical numbers. No critical numbers. Nope, we got one. Critical number 0. Nope. Critical number 1/4. So it's, oh wow. So it's between 50-50 chance now. No, oh, okay. You know what? I'm looking at the answer choices, and you can just get it right. Look what we said about extreme value theorem. It must have a what? And look what letter E says. So letter E's out. I don't want you to cheat the system. Try really hard not to do it. Not to do that. Try to sweat. I know some of you guys are like, no, I just want to get the answer and get this out of the way. But try. I want to. Anytime you do this, guys, obviously the answer is letter B just by looking at the answer choices. But if you have a closed interval, test your intervals, guys. I know. Okay, I know some of you are saying, why can't I do a sign chart? Because I don't go negative infinity to infinity. So just if you only have 3 points to analyze, just analyze those 3 points. F of negative 1, see what you get. Negative 1 squared is 1, 1 times 4 is 4, 2 times negative 1 is negative 2, 4 minus 2 is 2, 2 plus 1 is 3. So F of negative 1 is 3, unless I made a mistake, but check my work. And then I'm going to go F of negative 1/4. So negative 1/4 squared is negative 1, is positive 116 times 4. 4 goes into 16 4 times, so that's a 1/4. Plus, and then 2 times negative 1/4. 2 goes into 4 twice, so that's a negative half. So minus a 1/2. And then plus 1. Let's see, if I have a quarter and I subtract 50 cents, that's negative 1/4. And then I add 1, that's 3/4. But check, because sometimes I make mistakes. See? And then F of 0, that's going to be the easy one. If I plug in a 0 in here, you just get 1. So there it is. What's the biggest? F of negative 1. That's your absolute max. What's the smallest? F of negative 1/4, or at x equals negative 1/4, the smallest is 3/4, and F of 0 is nothing. So there it is. Critical number negative 1/4, local and absolute min. Oh man, I guess. Oh no, there it is. That we're done. I was gonna say I guess I got it wrong, but every absolute is a local, but not every local is an absolute. So we're good. How do we feel? Okay. Yeah, every absolute is a local, but not every local is an absolute. Find the critical numbers of f of x equals 3x square root of 5 minus x and classify the extreme values. Okay, this definitely has an endpoint. It looks like my domain is negative infinity to 5. But let's find our critical points by doing product rule with a little bit of chain, but it's not extreme chain. So here we go. F prime of x equals first times derivative of the second, 1/2, parenthesis 5 minus x, close it to the negative 1/2 times negative 1 plus second square root of 5 minus x times derivative of the first, 3. A little bit of algebra, not extreme. Let's see. What am I going to have? F prime of x equals negative 3x over 2 square root of 5 minus x plus 3 square root of 5 minus x. I'm going to equal that to 0. Man, Chav, I'm going to have to do algebra? Yes. Relax. Hopefully we're getting better at algebra now. I'm going to multiply this sucker by 2 square root of 5 minus x over 2 square root of 5 minus x to get the denominator to be this guy. And you make sure that there's no issues. 3x. Yeah, we're good. So here's what I have. I have negative 3x over 2 square root of 5 minus x plus 3 times 2 is 6. And then the square root goes away. So I have 5 minus x over 2 square root of 5 minus x. Are we still okay? Okay. Don't cancel out the 6 with the 2. So don't say 3 there because that's the whole point. We have to have a common denominator here. So distribute this guy in the top. Negative 3x plus 6 times 5 is 30 minus 6x over 2 square root of 5 minus x. We're still okay? Okay. In the numerator, I have negative 9x plus 30 over 2 square root of 5 minus x. Okay, now we can start talking about numbers. I'm going to equal that to 0. X equals 5 is an endpoint. So it's not a critical point because it's I know you're saying like, Chop, but it says that the derivative is undefined. You're right, the derivative is undefined at 5. But notice right here, guys, if I plug in a 5 there, that makes this 0. So it's an endpoint. At 5, you're on the x-axis. All right, but look at the numerator, equal that to 0. Negative 9x plus 30 equals 0. Negative 9x equals negative 30. Divide by negative 9. Divide by negative 9. X equals negative divided by negative is a positive. Delete anything. Oh, man. Delete anything that does not have 10 over 3 as a critical number. 0 is not a critical number, so out. No critical numbers out. Critical number is 0 and 1030. 0 is not a critical number. I'm going to put a star on this. Obviously, that's the answer. Critical number is 0. Nope, out. So look, you can just get the answer just correct. I know what I just said. That I don't agree with this one, but apparently UH does. UH is saying critical number 10 over 3 and 5. Let me tell you why I don't agree with 5. Because 5 is an endpoint. Anything bigger than 5, it's not a part of the domain. Let me write that down. Domain. The domain of this function is negative infinity, comma, to 5, bracket. So I'm not in agreement. I'm going to put an awkward emoji. I'm 100% not in agreement with that. I would take a guess that most professors would not call 5 a critical number. By definition, the derivative is undefined at 5, but there's nothing special going on at 5. It's just the end of my function. Does that make sense, guys? Okay. All right, so there it is. Just by looking at your answer choices, there's the right answer. But how do I know that that's an absolute maximum 10 over 3? I'm going to do a sign chart. And I stop right at 5. So don't go forever. It goes forever to the left, but not forever to the right. And I'm going to put 10 over 3 somewhere here. In case you want to know what 10 over 3 is, 369, it's 3.333333333, right? So in decimal, this is 3.333333333. All right, a number to the left of 10 over 3, like 0. All I care about is the numerator. The denominator is always positive. If I put a 0, I get a positive, plus. This is my F prime graph, my sign chart. If I put a number bigger than 3.33333, like 3.5, negative 9 times 3.5 is going to be bigger magnitude-wise than 30. So I have a negative plus 30. That's going to be a negative. Do you guys see that? So if I go from positive to negative, then I have to have a max. And it says absolute max because that's the biggest point on the entire domain. Cool or not cool, guys? All right. Question 9. Don't worry, guys. We're almost done. Question 9, I would actually do it by graphing. And don't worry, it's not extreme graphing. Look, all the lines are linear. So here's what I would do. I'm going to go slow, guys. Exaggerate quadrant 1 and 4, like this. And at 0, negative 4 times 0 is 0, so put it there. And at 1, notice that there's not an equal sign. Negative 4 times 1 is negative 4. So I'm going to say this is 1 right here, and I'm going to say negative 4 is right here. So I'm going to put an open circle right there, and I'm going to connect. Does everyone see how I did that? Then at 1 at this one, that one has an equal sign. What's 1 minus 5? You know what? I'll even circle what I'm doing. This one's in red, and I'm doing this one in green. 1 minus 5 is negative 4, so I'm back at that hole, and I'm going to plug it in. And I'm going to plug in a 6. 6 minus 5 is 1, so I'm going to say that 6 is way over here. It's not to scale. And 6 minus 5 is 1, and I'm going to say 1's right here. And that's a solid point. And there it is, guys. Boom. And then I'm going to do this one in purple. So I'm color coding it, guys, for you guys. All right, in purple. 7 minus 6 is 1. So I'm here. I'm going to put open dot, but notice that the green is closed. And I'm going to put an 8. I'm going to say 8's like right here. 7 minus 8 is negative. 7 minus 8 is negative 1, huh? So there's negative 1. Let me write the 8 a little small. And I'm like right here and a dot. All right, there it is. That's my function. That's F. This is what you call piecewise. This is what you guys were freaking out over with last year when you guys were juniors. But now, look, it's like a walk in the park. I hope it is. All right. Just looking at that graph, where do I have a min? Where's my absolute min? Yeah, my absolute min occurs at 1, which is negative 4. Look, that's absolute min. Where's my absolute max? Yeah, the absolute max is at 6, and the absolute value is 1. All right, look for that. Critical numbers 1 and 6. Yep, those are critical numbers. My derivative is undefined there because they're sharp corners. Local min and absolute min at f of 1. Yep. And local and absolute max at f of 6. Yep. There it is. Do you see how we did it, guys? Okay, last one. Yeah, last one. We're done after this. And look what it says. All right, guys, focus, because we don't want to get this one wrong. UH is being nice. Guys, focus. It says read carefully. See you guys later, guys. Have fun. The graph of f prime, the derivative of f, is shown below. Classify the smallest, underline that word, smallest critical number for f. In math, I know in physics, smallest is like magnitude, but in math, smallest is whatever is further left in the number line. Yes or no? All right. Read the number line left to right. Boom, critical number. That's what they wanted, right? Smallest critical number. What critical number is that? -3. Oh, they didn't want the number. They want to know what it is. My derivative is positive. This is f prime, and it goes from positive to negative. So if it goes from positive to negative, what is that on f? A max. There it is. Cool or not cool? Okay, last one. I thought that was the last one, but this is the last one. Look, they're both graphs, so it's going to be fast. Read carefully. The graph of f prime, the derivative of f shown below, classify the smallest critical number for f. Oh, it's the same thing. To classify the smallest critical number. Okay, left to right. Here it is. It's that guy right there. The derivative is, this is f prime. The derivative is going from negative to positive. So what is that on f? A min. So-called local min. Okay. Do you guys like when we go over these UH quizzes? Okay. So there it is, guys. Have at it. You got a lot of time. You got an hour. But, if you want a mental health day or whatever. All right. See you guys later. Not that you guys can't leave, but okay, I'll stop.